Alright, in this video we're going to talk about polynomials, really just like the definition of what a polynomial is and some examples of things that are polynomials, just so you have an idea of what we're talking about when we say the word polynomials. A lot of the work that you do in algebra and precalculus and even in calculus, you're working with polynomial expressions, and it's a word that you'll hear thrown around a lot, so it's important to know what that word means when you hear it. Alright, so a polynomial is an expression in this form: a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 plus a sub 1 x plus a sub 0. Right, so a lot of students look at that and say, well, that's super confusing because it's just a bunch of letters and numbers and stuff. It doesn't really make any sense. Right, so basically what a polynomial is, each one of these things here is what we call a term. The a with the x, right, each one of those is a term. The a sub n, the a sub n minus 1, those are what we call the coefficients. Those are usually just numbers that are in front of the variable x. Right, and they have these little n minus 1, 1, 0 here. We call those numbers and those n's and stuff the index. They're just kind of counting each different coefficient that we have. So like this is the first coefficient, this is the next one, all the way down to these over here. Right, so those are just kind of counting how many coefficients there are. But in a normal polynomial, as you see some of the examples down here, like 2x squared minus 3x plus 4, the a sub n minus 1, those are just some numbers. Right? And then the x raised to a power, x to the n power, x to the n minus 1. Right, normally we write polynomials with the highest exponent first, and then we put it in descending order of the exponents from there. A polynomial doesn't have to be written that way, but that's the conventional way that we write it. Right, so it's x to the n minus 1. The next one will be x to the n minus 2, until we get down to x to the first power, and then the last term, which is just that a sub 0, which is just a number. It's what we call a constant. It doesn't have that variable attached to it at all. So that's what a polynomial looks like. Basically, it's just a bunch of numbers multiplied by x's raised to powers, and then a bunch of those just added and subtracted to each other. Right? Now, the key thing of what makes something a polynomial is that the exponents on the x have to be positive whole numbers. Right, so if you have a negative exponent, it's not a polynomial. If you have a fraction or a decimal in the exponent, it's not a polynomial. If you have an x in the denominator of a fraction, it's not a polynomial. Right, so a polynomial is just x numbers multiplied by x's raised to powers, and those exponents are always positive whole numbers. Right, that's what makes something a polynomial. Right, and when you look down like the examples that are here of polynomials, you kind of get a feeling of what I'm talking about. An important aspect of a polynomial is the degree of the polynomial, right? The degree refers to the highest exponent that you have in that polynomial, right? So if x to the n power, if n is the highest exponent, then it has degree n, right? So the degree is just the highest exponent that you have on the variable in that polynomial expression. All right, so we have here a bunch of polynomials, the type of polynomials. Some polynomials have special names depending on how many terms they have. A list of the terms in that polynomial, and then the degree of the polynomial. Right, so the first example we have here, 2x squared minus 3x plus 4. Right, that's a polynomial. It's numbers multiplied by x's raised to powers, and the exponents on the x are positive whole numbers. Right, it's x to the second power, and then it's x to the first power. All right, we call this type of polynomial a trinomial because it has 3 terms. Right, that prefix tri means 3. If you ever rode a tricycle, you probably know that already. Right, so when you have 3 terms in your polynomial, we call that a trinomial. The terms in this particular polynomial are 2x squared, right, negative 3x, and then 4. Right, so we have 3 terms in this polynomial. Notice that minus in front of that 3x there, that makes that second term a negative 3x. Right, so those are the 3 different terms in this polynomial, and this polynomial has degree 2. Right, because the highest exponent, that x squared, is an x to the second power, so we have a degree of 2. Right, so the type of polynomial that we have, whether it's a trinomial or a binomial, refers to how many terms you have. The degree refers to what the highest exponent is. All right, so 2 different ways we can classify polynomials, by their degree and by their number of terms. So make sure you're straight as far as which one is which. All right, the next polynomial we have x to the 8th plus 5x. Right, again, it's numbers multiplied by x's raised to powers. The exponents are positive whole numbers, right? So that makes it a polynomial. Right, this one is a binomial because we have 2 terms. Right, that prefix bi means 2, just like I said, the trinomial is like a tricycle with 3 wheels. Well, a binomial is like a bicycle with 2 wheels. Right, so x to the 8th plus 5x is a binomial. It has 2 terms, x to the 8th and 5x, right? So the terms of a polynomial are the things that are separated by the addition and the subtraction, right? Whatever has a plus or a minus in between them, those are the separate terms, all right? And then this one has a degree of 8, right? The highest exponent, that x to the 8th power, makes it a degree 8 binomial, right? Degree 8, so it's an 8th degree binomial because it has an exponent of 8 and it has 2 terms. So 8th degree binomial is how we would classify this particular polynomial. All right, this one, 8 minus x plus x squared minus 1/2 x to the 3rd power. Right, I said when we were talking up here that normally you put the highest exponent first and then you go in descending order from there when you write a polynomial. But that's not a set rule that it has to be that way. Right, for this polynomial here, we see it kind of goes in ascending order from exponent. It has the constant first, 8, and then the minus x to the 1st power, the plus x to the 2nd power, and then the minus 1/2 x to the 3rd power. Right, so the exponents increase here, but it's still a polynomial, right? It doesn't have to be written in that descending order for it to be a polynomial, right? This polynomial is what we call a 4-term polynomial, right? We only have fancy words for polynomials that have 1, 2, or 3 terms. Anything more than 3 terms is just a polynomial with 4 terms or 5 or 6 or whatever it happens to be, right? So this one's a polynomial with 4 terms. The terms are negative 1/2 x to the 3rd. Again, that negative goes with that term that comes after it. So it's negative 1/2 x to the 3rd, the x squared, then minus x, and then the 8, right? Those are the 4 terms in this polynomial. And this one is a degree 3, right? So an important thing here, and the reason this one's up here, all right, the degree is not always the first exponent that you see in your polynomial. It's the highest exponent that you see in the polynomial, right? That highest exponent usually is the first term like it is in these up here, but the highest exponent could be the last term, right? So when you're classifying a polynomial, you're trying to figure out what the degree is. Don't just look at the first thing and say, oh, it's an 8, so that's degree 0, I guess, because there's no x there at all. No, this one's degree 3 because the highest exponent it has is that 3rd power that's at the end, right? So you have to look at every single term when you're trying to figure out the degree of the polynomial. You know, this one here could be 2x squared. The next one could have been negative 3x to the 5th power. That would have made that a degree 5 polynomial. All right, so you have to watch out for that. All right, the next one here, 5x plus 1. All right, so there's 2 terms here, right? The 5x and the 1. So this one is a binomial because it's 2 terms. And since the highest exponent I have on the x is a 1, right? It's 5x to the 1st power. It's a 1st degree binomial. All right, so it's a degree 1. This one, 9x to the 5th power. Well, this one just has one single term, right? It's just that 9x to the 5th. Nothing's being added or subtracted to that. Remember, the terms are separated by addition and subtraction. Right? You want to say, well, it's 9 times x to the 5th, so my terms are 9 and x to the 5th. You know, the stuff that's multiplied together makes a single term. The addition and subtraction is what separates the terms. So this one is just a single term, the 9x to the 5th, which makes it a monomial. Oh yeah, it looked like I spelled it wrong, but it's actually spelled right. Right, so anything, a polynomial that has one term we call a monomial, right? Mono means 1. Right, so monomial. And it's a degree 5 monomial, right? Because it's an x raised to the 5th power. All right, and then the last one up here, 6, right? So even just a plain number like 6 is technically a polynomial, right? This one we call a monomial because it's just the one term, right? The term is 6. This is a 0 degree polynomial, right? Because it doesn't have an x to a power at all. Technically, it has an x to the 0 power. If we recall, anything raised to the 0 power equals 1. Right, so it's really 6x to the 0 power, which is 6 times 1, which just equals 6. Right, so even a number is a polynomial. It's like the most boring type of polynomial. It's just a monomial of degree 0, but still, technically, by the definition of a polynomial, it is a polynomial. All right, so those are some examples of polynomials. The key things to keep in mind are just what a polynomial looks like. Remember, it's numbers multiplied by x's raised to powers, a bunch of those being added or subtracted. And the exponents have to be positive whole numbers, right? No negative exponents, no fractions or decimals, no x's in denominators of fractions, right? If you don't have any of those things, you've got a polynomial. The monomial, binomial, trinomial, you know, that's how many terms it has, 1, 2, or 3. Anything above that, you just say 4 or 5 terms or whatever it is. And then the degree of the polynomial is the highest exponent on the variable that polynomial has, right? And again, this is the kind of thing where as you move forward through algebra and precalculus and calculus, you know, we talk about polynomials and binomials and trinomials all the time. We talk about the degree of the polynomial. So these are terms that you'll hear a lot. So it's important to understand what it is that we're talking about when we say those things.